Hi everyone, what I want to do now is I want to go over this classwork from April 20th, from 4/20/20. It's basically our first video getting into trigonometry. First thing I want you to do is watch this video here for number one. Take some detailed notes and send me those notes. Then I want you to answer these questions right here. What acronym presented in the video will help you remember the trig ratios? If you watch that video, it should be pretty clear. And then, what are the three equations related to the acronym? And pretty soon if you watch this video, you'll get that information as well. So for part 4, I've got 4 example problems. I actually worked out a problem. This one over here, I put the answers for it. So that will help you, but also this video will hopefully help as well. So I think what I'm going to do is I'm going to do 1 and 2 here for number 4, and then for number 5 it actually gets into it as well. So for number 4 it says, for the following problems, label each side as adjacent, opposite, and hypotenuse with respect to the reference angle. Then we got some stuff here that I'll probably explain in the video. Once you do that, once you label all the sides as adjacent, opposite, and hypotenuse, I want you to actually figure out, like if you know those things, what's the cosine of z, what's the cosine of c, what's the tangent of c. So hopefully that'll help. I think I'm actually going to do 1 and 3. So I'm going to grab these guys right here. Okay. So here's my work here. So for number 1, for this first instruction, it says, for the following problems, we just got to label adjacent, opposite, hypotenuse. That's all I want to do first. So let's practice that, okay? Let's see. So we got adjacent, opposite, and hypotenuse. First off, if this only applies to right triangles. The hypotenuse is always the longest side, so you can go look at this and just pick the biggest number. It's also always across from the right angle, is the hypotenuse. So I'm going to label this as H. So let's do the same thing for number 3. Which of these is the biggest number, which one of them is across from the right angle? You can also think of what does the right angle point to? You see what it points there? So that's right here. And this would be the hypotenuse. All right. That's all I was actually going to do for that one. So now let's do a different color to find the opposite. So I think hypotenuse is always the easiest one to find. The next one is the opposite. So now opposite and adjacent depend on what angle you're looking at. So we're looking at angle Z, okay? Because we're looking at angle Z, this is our reference angle here. I'm going to mark it as our reference angle. So our reference angle here is Z. What is opposite to Z? Opposite, I want you to think of across for the reference angle. It's never across from the right angle, it's always across from the reference angle, whatever you're finding a cosine, tangent, or sine of. So that would be across over here. And that's our 9. So I'm going to label this side as our opposite. Now the only one left has got to be adjacent. So I'm going to label this one right here as the adjacent. But if you think of it in respect to Z, Z is right here. A is the one that's adjacent, means next to. A is next to, the 12 is next to Z. Whatever side is next to it that isn't the hypotenuse, because you determine the hypotenuse first. So opposite, adjacent, hypotenuse. So let's try this one down here. Our reference angle is C. With respect to C, what is opposite? What is across from C? That'll get us over here to 40. I'm going to label this as opposite. And now whatever's left has to be the adjacent. So I'm going to label this one right here as adjacent. And if you check, 30 is next to the angle C, whichever isn't the hypotenuse. So that's actually all you have to do for part 4, for this first step. And so I want you guys to do it for 2 and 4. What is the opposite? What is the adjacent? What I'm going to do now is look at part 5. So the number 5 says, now you've labeled the sides of the above triangles, find the trig ratio. So what are our trig ratios? That's where it comes back in, where we can answer these questions. What's the acronym? what are the equations? So let me go down to this one right here. Okay, so now what I'm doing is more of our, put a little wall here. Now we're on, oh wow. Okay, that works. Now we're on part 5. Okay, so let's see. Custom pen, I'll change the color now. We're doing something a little bit different. Let's do purple. Okay, so remember, we're dealing with the cosine here. So that's going to depend on our trig ratio since we're doing the cosine. So real quick, let's just do a little review. The acronym we need to know, that's your SOHCAHTOA. SOHCAHTOA. So if you know this acronym, that's a TOA there. If you know this acronym, that basically helps you solve the rest of these equations. So we got SOHCAHTOA. That basically stands for sine of theta. Theta is a general angle. Usually we use theta, but here, for instance, we're doing Z or C. So I could have labeled any of these angles as theta. So sine of theta is the opposite over the hypotenuse. See how that comes into play where, sine is the S, O is the O, H is the H here. So hopefully that makes some sense there. So that's our sine equation. Now let's do our cosine equations. Cosine of theta is equal to adjacent over hypotenuse. A over H. And you can compare it to this. A over H, cosine is equal to A over H, adjacent over hypotenuse. The last one is tangent. And by now you guys should get the pattern. Maybe you can fill this in on your own. The tangent of theta is equal to opposite over adjacent, TOA. O over A. Okay, great. So this is our acronym. These are the 3 equations. So I basically answered these 2 for you in that process. But let's go back to 5. What is the trig ratio? For number 1, we're doing the cosine of Z. So we already labeled it with respect to Z, so that's great. So the cosine of Z, remember that cosine is equal to, so cosine of Z is going to be equal to adjacent over hypotenuse. Our adjacent is 12. And our hypotenuse is 15. So 12 over 15. And I'm actually okay with you guys just leaving it like that. If you wanted to, you could simplify this fraction. 12 and 15, a 3 goes into both. So you could simplify it to 4. 12 divided by 3 is 4. 15 divided by 3 is 5. You could answer it as this, or you could put this into your calculator. And 4 divided by 5 will be 0.8. So any of these answers are sufficient. So I'm going to highlight all of them. And this is all you have to do for, I guess, question 5 over here, like this part. And really, you only have to do one of these. You can just write 12 over 15 if you want to. Now, let's do it for this one. I want you guys to try it out on your own. Maybe pause the video, see if you get what I get. But if not, I'm going to start moving. Tangent is opposite of adjacent. So the tangent of C, and remember, we already labeled it. That was the first step. The tangent of C is equal to, tangent is opposite of our adjacent. What's our opposite? Our opposite was 40. 40. Opposite of our adjacent, what was our adjacent? Our adjacent was 30. And you guys can leave it like that, 40 over 30. So that can just be your answer. An alternative thing you could write is you could simplify this to 4 over 3. Or you could put in your calculator, get a decimal, and you'll get 1.33333. It'll go on forever. I'm just going to stop at 1.33. It's a decimal here, 1.33. So that's how you do 1 and 3 here. I want you guys to go through the process for 2 and 4, basically doing the same thing I just did over here.